Okay, so I want to just talk about this gas law stoichiometry worksheet here. I did all the work here, and I provided the answer for you in the assignment. But let me just talk through a couple of these things. First of all, I try to help you out here a little bit and create this little key here. Uh, Anything that is highlighted in yellow is what we're looking for, what we want. Anything highlighted in green is what you have or what you're given. Everything in orange are the conditions that we're given. So meaning like the temperature and pressure that we're given. And anything in this purple, you can just ignore. So if you see it in purple, you can ignore it. You don't have to worry about that. Okay. So a lot of these gas law stoichiometry problems, they're very similar to regular stoichiometry problems. However, they throw the gas laws in there. Okay. And if it's at STP, so for example, this first one, we have this reaction and it's occurring at STP. So the conditions are standard temperature and pressure. Okay, when we have standard temperature and pressure, that means that all gases, 1 mole of any gas will occupy 22.4 liters of space. So that really helps us out because we don't have to use the ideal gas law in this instance. We can just use this relationship. The 1 mole is 22.4 liters. Okay. So for example, here, if we start with 5 liters of N2 and we want to figure out how many liters of NH3 we make, okay, basically we're going to go from liters of N2 to moles of N2 by using the relationship where 1 mole is 22.4 liters. Then we're going to use molar ratio to find NH3, so NH3 over N2, and then finally go back to liters of gas. Okay, and if you see, actually we do this anytime we're at STP and we're going from liters of one thing to liters of another, we're always going to be converting it twice. So we can kind of actually ignore these things. We can cross those out. We can ignore them, and we can just use molar ratio because all gases at STP occupy the same amount of space. So we can ignore that. We can ignore these two little things here. Okay. The next one. The next one we have to use because we're not at STP. We're not at STP here. We're at a pressure of 12.4 atm and a temperature of 85 degrees Celsius. So I always convert the temperature first before I do anything. So I converted 85 degrees Celsius, added 273, get 358. Okay. Okay. And because of this, I know eventually we're going to have to use PV equals nRT. Okay, eventually. We might have to do in the beginning, the first step, or the last step. Okay, we have to look at our situation and figure out what we're going to do. Okay, so here we want to know how many liters of ammonia gas can be made from 55 grams of nitrogen, okay, and excess hydrogen. So we can ignore the hydrogen. We don't have to worry about that. Okay, so the first thing we're going to do is figure out how many moles of nitrogen we can make. Moles of how many moles of ammonia. This is actually wrong here. This should say NH3. Oh, I got to fix that. That should say NH3. My bad. So we're going to do that by converting grams of N2 to moles of N2, then moles of N2 to moles of NH3. So converting grams of N2 to moles of N2 by dividing by the molar mass, and then multiplying by the molar ratio to find moles of NH3. So that should be NH3 there, not N2. I did the work correct, I just labeled it wrong. Okay. All right. So once we find out moles of N2, it doesn't want us to find the answer in moles, it wants us to find the answer in liters. So we're going to use PV equals nRT, the ideal gas law. So the pressure is 12.4 atm. The volume is what we're looking for. The number of moles of gas we got here in our problem. And then R is always the same, 0.0821. And the temperature is what we were given in the beginning as well, 358. And we solve for V. So divide both sides by 12.4, and we get 57.6 liters of NH3. Okay, next one. I just realized I don't have a number 4 there. That's weird. Goes 3, then 5. Well, I guess I don't like the number 4. I probably deleted it and then just never replaced it. Okay. The next one, number 3, how many liters of ammonia gas, so that's what we want to know, can be made from 34 grams of nitrogen gas, an excess amount of hydrogen, so we can ignore that, and our conditions are STP, standard temperature and pressure. So we can use 1 mole as 22.4 liters. So this is when we start with grams of N2. We always want to convert from grams to moles, so divide by the molar mass. Then we want to find moles of NH3, so we use the molar ratio. That's what's going on here. That's the molar ratio, 2 NH3 for every 2 N2. And then at STP, we're lucky here. We can just use this rate, 22.4 liters for every 1 mole. And we get 27.2 liters of NH3. Okay. The next one, number 5, make sure you balance it first. And it's the same process I just did for number 3. Same process. Because we're at STP, we can use the 22.4 liters. Okay. Number 6 is the same process as we did for number 2. So the first thing we did was we found out how many moles of O2 we can make by using regular stoichiometry. And then once we find out moles of O2, we can use PV equals nRT to find the volume of O2. Okay, I know I'm going kind of quick here, but if there's any problems you'd like me to go over more slowly and more thoroughly, please let me know. Number 7 is just, we're using STP, so it's 22.4 liters. So doing it the same way we did number 1. Same way, actually number 3. Same as number 3. Number 8 is a little bit different. Number 8 is actually very similar to what we just did in number 4, or not 4, we don't have 4. In number, we're gonna have to use PV equals nRT, so it's just like number 2. However, this one is a limiting reagent problem. We need to figure out what one is gonna limit us on how much product we can make. So we take the 10.3 grams of M3N2, figure out how many moles of NH3 we can make. Do the same thing for the 10 grams of H2O, see how much NH3 we can make. Okay, whatever one makes the least is going to be how much we can make. So this one makes the least, that means it's going to run out first. So that's our theoretical yield of NH3. So that's how many moles of NH3 we can make. And then we're going to plug that into our PV equals nRT, where this is our number of moles. Okay, and once we solve for volume, you get 4.9 liters. Okay. Number 9 is very similar to the one we just did, except that's not a limiting reagent problem. Super easy. Number 10 is a little bit different. Number 10, this one we actually we got to do PV equals nRT first. So in this case, we're given 20 liters of oxygen. Okay, we need to convert from 20 liters of oxygen to moles of oxygen first. We need to figure out how many moles that is. Okay, so we do that. You use PV equals nRT. We use 1.3 atm. 20 liters of O2 is the volume. We're looking for N. R is always the same. T is 263. Okay. Solve for N. We get N is 1.2 moles. That's not the answer though, because we have to then figure out, well, if we have 1.2 moles of O2, how many grams of H2O can we make? So we go moles of O2 to moles of H2O using molar ratio, and then moles of H2O to grams of H2O by multiplying by the molar mass. Again, we get 15.6 grams of H2O. Okay. Okay, so any of those you'd like to have questions about, let me know. Otherwise, that's as much as I'm going to go over, and I am willing to go over it more carefully if you want me to next time. Just ask me a question, okay?